All right, today we're stepping into the lab, but we're not just running an experiment. We're going to be detectives. We're treating this whole thing like a crime scene, with two unidentified substances as our mysterious subjects. Our mission? To uncover their true identities. So just imagine for a second, someone hands you two vials. No labels, no hints, nothing. Just a couple of mystery substances. What do? I mean, where do you even begin to figure out what you're looking at? Well, you treat it like a crime scene. Seriously. Every single color change, every bubble, every solid that suddenly appears, that's a clue. You can think of our test tubes as interrogation rooms, and the chemicals we add, those are the questions we're asking. Okay, let's open up the case file. Our subjects are a dark crystalline solid we're calling FB6 and this intriguing blue solution codenamed FB7. They've both got a story to tell, and believe me, we're going to make them talk. We're going to start with our first subject, FB6. You know, sometimes the simplest, most direct way to get a solid to spill its secrets is to just, well, turn up the heat. Let's see how it handles the pressure. Now, of course, there's a proper procedure for this, kind of like a forensic protocol. We put the sample into a special hard glass tube, start by heating it gently, and then we really crank it up. But the most important step, we've got to be ready to capture and identify any gas that tries to escape the scene. Okay, so let's look at the evidence, because the clues here are just fascinating. First, the solid starts to pop and crackle. That's a physical thing called decrepitation. It's just trapped water turning to steam and busting out. But then, check out clue number 2. A gas is released that relights a glowing splint. I mean, that is the absolute smoking gun, the unmistakable test for oxygen gas. And finally, look what's left behind, a totally new black substance. There is no doubt a major chemical change has happened here. So what we've just witnessed is called a thermal decomposition. We've literally used heat to break our substance down into simpler parts. And this whole process, it acts like a unique chemical fingerprint that helps us zero in on what our original compound really is. The original substance might be gone, but it left behind a key witness, that black residue. The investigation is far from over. It's time to put this residue in the interrogation chair and get the rest of the story. And this is brilliant because it shows how asking different questions gets you different answers. When we put the residue into plain water, we get a purple solution. But when we put it in an alkali, sodium hydroxide, it turns green. This tells us the residue has the manganate Vi ion. See, that ion is only stable in an alkaline environment, which is why we see green. In regular water, it gets unstable and actually changes back into the purple permanganate ion. This is a huge piece of the puzzle. So we have the original purple color, the fact that it produced oxygen, and the revealing behavior of its residue. The evidence is conclusive. Subject FB6 is potassium manganate 7, also known as potassium permanganate. Case number 1 is officially closed. All right, let's move on to our second subject, the solution FB7. Now this one's going to be a bit tougher. It's already dissolved, so heating it isn't going to tell us much. We're going to need a more sophisticated two-pronged attack to crack this case. So our first line of questioning for FB7 is to bring in some aqueous ammonia. This is a go-to reagent for identifying metal ions in a solution. Let's see what happens. And whoa, the results are pretty dramatic. Take a look. A few drops of ammonia, and we get this pale blue solid. That's a precipitate. But here's the crazy twist. As we add more ammonia, that solid completely vanishes, and the whole solution turns this stunning deep royal blue. This exact sequence of events, precipitate forms, then dissolves into a deep blue, is a massive clue. And yeah, this is a signature move. Any chemical detective worth their salt knows that this specific reaction, a blue precipitate that dissolves in excess ammonia to form that deep blue solution, that is the calling card of the copper-2 ion. We have our first prime suspect for the cation. But hold on, we're not done yet. We've got a suspect, but we need more evidence. What happens if we introduce a new chemical, hydrogen peroxide, into this deep blue solution? Let's see if we can get it to talk some more. And yup, the plot thickens. The solution starts fizzing and turns this dark color, and that gas that's bubbling off, it relights a glowing splint. It's oxygen, our old friend from the first case. This tells us our copper ion isn't just sitting there, it's acting as a catalyst, speeding up the breakdown of the hydrogen peroxide. Another piece of the puzzle just fell right into place. Okay, Time for our second line of attack. The ammonia test strongly points to copper, but a good detective always confirms their suspicions. So we're going to use a classic two-step reaction with potassium iodide and then sodium thiosulfate to get that definitive proof. Let's break this down. Adding potassium iodide gives us two things: an off-white solid, that's our evidence, and a messy brown iodine solution that's hiding it. So to see our evidence clearly, we basically need to clean up the crime scene. That's where sodium thiosulfate comes in. It gets rid of that brown iodine, making the off-white precipitate of copper 1 iodide perfectly visible.
Okay, we've gathered overwhelming evidence. The positive ion, our cation, is definitely copper 2. But every salt has two parts. We've identified one half of the partnership. Now we need to identify the other, the negative ion, the anion.
Our case file has narrowed it down to two possibilities. Is our mystery anion the sulfide ion, or is it the sulfate ion? They look pretty similar on paper, so we're going to need one final, definitive test to tell them apart. And here it is, the final verdict. We add our chosen reagent, barium chloride, and a thick white precipitate forms right away. Now, this could be barium sulfite or barium sulfate. The deciding factor, the final question, is adding acid. Barium sulfite would just dissolve, but as you can see, our precipitate doesn't. It stays solid. That insolubility is the last irrefutable piece of evidence we need. Our anion is sulfate.
We've followed all the clues. We've analyzed all the evidence. We've interrogated all the witnesses. It's time to bring all the pieces together and finally unmask the true identity of substance FB7.
The cation is copper 2. The anion is sulfate. Put them together, and the identity of FB7 is revealed to be copper 2 sulfate. Case closed.
So what's the big takeaway from our investigation? Well, we saw how a simple heating test can reveal a hidden gas, and how a sequence of color changes can unmask a very specific ion. Each test is a question, and every reaction is an answer. It really shows that even on a molecular level, every substance has its own unique story to tell, if you just know how to ask the right questions. We cracked the case of FB6 and FB7 just by thinking like detectives. Kinda makes you wonder, doesn't it? If a simple set of tests can reveal the hidden identities of these two substances, what other secrets and stories are locked away, just waiting to be discovered inside a test tube?